Hello, this is Chapter 4 Review, Part 2. So number 6 says, find the second derivative of y equals negative x squared plus x. To take the second derivative, we take the derivative once, and then we take the derivative again. So the first derivative would be y prime. The derivative of negative x squared would be negative 2x. Derivative of 1x would be 1. So the first derivative would be negative 2x plus 1. To find the second derivative, y double prime, the derivative of negative 2x is negative 2, and the derivative of 1 is 0. So the second derivative, y double prime, would equal negative 2. Question 7. Find the second derivative. So we have y equals negative 2 over x squared plus 3x to the 6 minus 4x. I would, step 1, rewrite it. So instead of having negative 2 over x squared, I would do y equals negative 2x to the negative 2 plus 3x to the 6 minus 4x. Then we take the first derivative, y prime. The derivative of negative 2x to the negative 2 would be 4x to the negative 3. The derivative of 3x to the 6 would be 18x to the 5th. And the derivative of minus 4x would be minus 4. Then we take the second derivative, which would be the derivative of 4x to the negative 3 would be negative 12x to the negative 4. The derivative of 18x to the 5th would be 90x to the 4. And the derivative of minus 4 is 0. So our second derivative would be negative 12. You can take that x to the negative 4, move it to the denominator, so it would be negative 12 over x to the 4 plus 90x to the 4. Okay, question 8. Find the second derivative of y equals e to the negative x plus e to the x. So the first derivative, the derivative of e to the negative x, you step 1 rewrite it, e to the negative x, and then the derivative of the exponent, the derivative of negative 1x is negative 1. Plus the derivative of e to the x is e to the x. So we'll simplify along the way. So instead of having e to the negative x times negative 1, we can say the first derivative is negative e to the negative x plus e to the x. Then take the derivative, so the negative stays in front. Rewrite e to the negative x, e to the negative x, and the derivative of negative 1x is negative 1, plus the derivative of e to the x, e to the x. Then we'll simplify again. Negative times negative 1 would be positive, e to the negative x, plus e to the x. Question 9. The following formula gives the oxygen consumption in milliliters of a bird embryo for the time the egg is laid through the bird hatches in days. So we have O of t equals negative 0.065 t cubed plus 3.4 t squared minus 22t plus 3.6 from t of 8 to 30. So remember, our input t is in days and our output is oxygen consumption in milliliters. So we're given that the window for x is 8 to 30 days, 8 to 30, and then the minimum is from 0 to 1,000. So our y minimum is 0, our y maximum is 1,000, and then we graph the original function. You can see how it changes. So if I want to find the oxygen consumption of day 20, you take 20, plug into the original function, and you get 403.6. So at day 20, the oxygen consumption is 403.6 milliliters. If I'd like to find the rate of change of the oxygen consumption, I would take the derivative, the first derivative of the original. So the original is negative 0.065 t cubed plus 3.4 t squared minus 22t plus 3.6. The derivative of that would be negative 0.195 t squared plus 6.8 t minus 22. And what is the rate of change of the oxygen consumption on day 20? We plug 20 into the first derivative, and we get 36. So at day 20, the rate of change of the oxygen consumption is increasing 36 milliliters per day. Now, what is the function to find the rate of oxygen consumption's acceleration? So when I say acceleration, that's second derivative. So we take the derivative again. So the derivative of negative 0.195 t squared plus 6.8 t minus 22 would be negative 0.39 t plus 6.8. And then when we plug 20 into the second derivative, we get negative 1. So at day 20, the oxygen consumption is decelerating at 1 milliliter per day squared, Okay, question 10. Given the function f of x equals 3x to the third plus 9x squared minus 720x minus 15 from negative 12 to 10 would be the domain, find the x-intercepts and y-intercepts. So remember, to find any x-intercepts, you make y 0. So we take the original function, set y equal to 0, and I could use the calculator for this. If you plug the original in y1, 3x cubed plus 9x squared minus 720x minus 15, and y2 set 0 in an appropriate window, which I'll show below, and you find that the intersection is negative 0.0210. That would be your x-intercept. To find the y-intercept, you make x 0. So if I plug 0 into the original, remember x-intercept and y-intercept go back to the original, you get negative 15. So we have a y-intercept at 0, negative 15. Then it asks, are there any vertical asymptotes or horizontal asymptotes? Remember, for vertical asymptotes, we see if there's any place where the original is undefined, none. And then for horizontal asymptotes, again, we have those three possibilities for horizontal asymptotes you may want to review, but in this case, we're not dividing. There's no numerator, denominator, or two functions, so there's no horizontal asymptotes. This is a continuous function. To do stationary points, we take the derivative, set equal to 0. So the derivative is 9x squared plus 18x minus 720 equals 0. So we take the derivative of the original, set equal to 0. You can factor out the 9, and then you have x plus 10 times x minus 8. So we have two answers, x equals negative 10, x equals 8. Or we could use quadratic formula where a is 9, b is 18, c is negative 720. So possible stationary points are negative 10, 8. And then singular, take the derivative, see if there's any place where it's undefined, none. No number would make it undefined, no singular points, and endpoints given by the domain, negative 12 and 10. And if we graph the original function, which is 3x to the third plus 9x squared minus 720x minus 15, from negative 12 to 10, looking at the y values that we're looking at. So when you plug in negative 10 to the original, you get 5,085. 8 into the original, negative 3,663. Negative 12 into the original, you get 4,737. Plug 10 into the original, you get negative 3,315. Looking at the y values, the lowest is negative 3,663, so I went to negative 4,000. The highest is 5,850, so I went to 6,000. And then we'll look at each point. So negative 10, 5,085. That would be an absolute max. The next point, 8, negative 3,663. That would be an absolute minimum. The next point, negative 12, 4,737. That would be a minimum, but it's not the lowest point in the entire graph, so that would be a local minimum. And then 10, negative 3,315, which would be here, would be a maximum, but it's not the highest point of the entire graph, so that would be a local max. To find points of inflection, you take the second derivative. So remember, the first derivative is 9x squared plus 18x minus 720. The second derivative of the derivative of 9x squared is 18x. Derivative of 18x is 18. Derivative of negative 720 is 0. Then we set 18x plus 18, the second derivative, equal to 0. Subtract 18 to both sides. 18x equals negative 18. Divide both sides by 18. X equals negative 1. We take negative 1, plug it into the original function, we get 712. So we have an inflection point at negative 1, 711. Negative 1, negative 711 would be here. That's where it changes from concave down to concave up. So we can verify that with a graph. So we have an inflection point at negative 1, 711. When is the graph concave up? If you look at the graph, it is concave up from that negative 1 on to 10. And when is it concave down? It's concave down from negative 12 to negative 1. Notice it includes negative 12, parenthesis at negative 1, that's when it's concave down, and then parenthesis at negative 1 all the way to 10, including negative 10, bracket, is when it's concave up. Okay, question 11. Given the function x squared plus 1 over x squared, we'll go through the same steps again, this one. So to find the x-intercept, you make y 0. So if we set the original equal to 0, x squared plus 1 over x squared equals 0. To solve algebra, we subtract 1 over x squared, subtract 1 over x squared. So we have x squared equals negative 1 over x squared, cross multiply, x squared times x squared is x to the 4, 1 times negative 1 is negative 1, we have x to the 4 equals negative 1, x to the 4th power cannot equal negative 1, so there's no solution, therefore no x-intercept. To find a y-intercept, you make x 0. If I plug 0 into the original, you get undefined, so therefore there's no y-intercept. Looking at the graph again, we can see if there's any vertical asymptotes. Looking at the original, the 0 would make it undefined, so we have a vertical asymptote at 0. And then for horizontal asymptote, we could simplify the original to have x to the 4 plus 1 over x squared, basically trying to find a common denominator here. This would be x to the 4 over x squared plus 1 over x squared, so x to the 4 plus 1 over x squared. And remember your rules for horizontal asymptotes. If the degree of the numerator is larger than the degree of the denominator, there's no horizontal asymptote. Then for the extrema, we take the first derivative of the original. The original is x squared plus x to the negative 2. The derivative would be 2x minus 2x to the negative 3. Set that equal to 0. So if you had 2x minus 2 over x to the third equals 0, add 2 over x to the third to both sides. 2x equals 2 over x cubed. Cross multiply since we have a proportion. 2x times x cubed is 2x to the 4. 2 times 1 is 2. 2x to the 4 equals 2. Divide both sides by 2. X to the 4 equals 1. Therefore, x equals plus or minus 1. So you have two possible, negative 1 and 1. Singular points, what would make the derivative undefined? 0. And endpoints, none were given. So we have 0, negative 1, and 1. Remember, we plug those into the original, so negative 1 into the original would give us 2. 1 into the original would give us 2. And 0 into the original is undefined, so it wouldn't be a max or min. If we graph the original from negative 5 to 5, and from 0 to 5, this would be our graph. Notice the 2 points that we have, negative 1, 2, and 1, 2, are both minimums. They're both the lowest. So that would be, we have both of them being absolute minimums. To find point of inflection, you take the second derivative. So we have our original, x squared plus x to the negative 2. The first derivative is 2x minus 2x to the negative 3. The second derivative would be derivative of 2x is 2. Derivative of negative 2x to the negative 3 is plus 6x to the negative 4. Set that equal to 0. 2 plus 6 over x to the 4 equals 0. Subtract 6 over x squared. Subtract 6 over x squared. 2 equals negative 6 over x to the 4. Subtract 6 over x to the 4 minus 6 over x to the 4, which gives us 2 equals negative 6 over x to the 4. Cross multiply. 2 times x to the 4 equals 1 times negative 6. So 2x to the 4 equals negative 6. Divide both sides by 2. X to the 4 equals negative 3. X to the 4 cannot equal negative 3, so no solution, no points of inflection. And if you look at the graph, it does not go from concave up to concave down. It's concave up, concave up. So when is the graph concave up? From negative infinity to 0, and from 0 to infinity. And when is the concave graph down? It's not concave down. Thank you.